how many how many bricks will be required how many bricks will be required to construct a wall 13.5 meter long, 6 meter high, and 22.5 centimeter thick. If each brick measures if each brick measures 27 centimeter into 12.5 centimeter into 9 centimeter. So in this question we have to find how many bricks are required to construct a wall which is 13.5 meter long, 6 meter high, and 22.5 meter centimeter thick. If we construct the wall with the help of bricks and the bricks dimensions are given to us, that is this one. Now with the help of these bricks you have to construct a wall. Let's draw the picture of it. That can be easily understood then. Let's say first of all we draw a wall. It is given that the wall is 13.5 meter long. This is the wall, 13.5 meter long, and it is 6 meter high. Let's say this is 6 meter high wall, and it is only 22.5 centimeter thick. See the unit carefully. That is 22.5 centimeter. So this is nothing but the length of a cuboid, this is nothing but the breadth of the cuboid, and this is nothing but the height of the cuboid. This is our wall. Now we have to create this wall with the help of a brick, and the dimension of the bricks are given to us. The dimensions of the bricks are given to us. Let's say this is a brick. So its dimension are given to us. Its length is 27 centimeter. That is our L. Its breadth is 12.5 centimeter, and its height is 9 centimeter. Now with the help of this brick we have to construct this wall. So we have to find how many such bricks are required. Let me suppose that n bricks are required to construct this wall. So this wall is constructed with the help of these bricks, n bricks. So their volumes must be equal. So the volume of this brick is nothing but L into B into H, and the volume of this wall is nothing but capital L into capital B into capital H. So we have to equate their volumes. So n times the volume of brick, that is small l small b h, is equals to capital L capital B capital H. So number of bricks is equals to capital L capital B capital H divided by small l small b small h. Now what we see here, the some units are in meter and some units are in centimeter. Now we have to convert all the units in, let's say, centimeter. So on the upside, that is length is 13.5 meter, so we have to convert into centimeter. So we have to multiply it by 100. Now breadth is in centimeter, so there is no need to convert. The height is 6 meter, so we have to multiply with 100 to convert it into centimeter. Now it is divided by the length, the volume of the brick. The volume of the brick, all the units of the bricks are in centimeter, so there is no need to convert it. So 27 into 12.5 into 9. Now we have to remove the decimals. Now first we remove this decimal. We have to put 1 0 at the downside. We remove this decimal. We have to put one more 0 at the downside, and the denominator side we remove this decimal. We have to put one more 0 on the upside. Now we cancel all the zeros. Now what we see here, this 225 and 125 are get cancelled with 25. Now we have to cancel it with 25. 225 divided by 25 we get 9. 125 divided by 25 we get 5. 9 and 9 are get cancelled, and 5 120 times. Now 135 and 27 are get cancelled with, let's say, 9. 9 3 is 27, and 135 it is cancelled with 1 5 15 times, and 15 is cancelled with 3 5 times. So what is our answer? So 5 into 20, that is 100. 100 into 6, that is 600. Now 600 in 10, that is 6000. So the number of bricks that is required to construct the wall is 6000. You to need 6000 bricks to construct the wall. So that is our answer. Now we move to the next question. Now we have three metal cubes. Three metal cubes whose edge measures 3, 4, 5 centimeter respectively are melted to form a single cube Find the side of the new cube formed. Find the side of the new cube formed. Now let's see the solution of this. So in this question we have three cubes. The first cube is of dimension 3, and another cube is of dimension 4, and we have another cube of dimension 5. All these three cubes are melted to form a single cube. Let's say this is a big cube that is formed by melting these three cubes. Let's say the side of this cube is A. And the side of this cube is A. Now, when we melt, or when we are converting one thing into another by melting, the volumes remain the same. So the volume of all these three cubes should be equal to the volume of this cube. And the formula for the volume of cube, we know that is the volume of cube is side cube. So 3 cube, the volume of this cube, the volume of this cube is 4 cube, the volume of this cube is 5 cube. So we have to add these volumes. Now the volume of all these three cubes is equals to the volume of this big cube, that is A cube. 3 cube, we know that it is 27. 4 cube, that is 64. 5 cube, that is 125. That should be equals to A cube. Now 27 plus 64 plus 125, what we are getting? 216 A cube. And we know that the cube of 6 is 216. So the value of A is 6. Or we can say the side of the new cube is 6 centimeter. So this is our answer. The side of the new cube is 6 centimeter. Now we move to the next problem. A cube of side 9 centimeter is immersed completely into the rectangular tank containing water if the dimension of the base are 15 centimeter and 12 centimeter, 15 centimeter and 12 centimeter, then find the rise in water level. So in this question, what we have given to us, we have given a cube of side 9 centimeter. Let's say this is a cube of side 9 centimeter. The side of the cube is 9 centimeter is given to us, and we have a rectangular tank that is in the shape of a cuboid. Rectangular tank is nothing but a cuboid. Let's say draw a cuboid. This is cuboid, and whose base are given to us. The dimension of the base are given to us, that is 15 centimeter and 12 centimeter. So its length is 15 centimeter and the breadth is 12 centimeter. Now there is some water in it. Let's say up to this height there is a water inside it. There is water inside it. Let's the initial height of the water is h. This is the length. This is breadth. Now this is the initial height of a water level in the tank. Now when we immerse this cube, when we are immersing this cube into this water, when we are immersing this cube into this water, what will happen? When we are immersing this cube in this water, due to immersing of this cube in this water, the water level get increased. The water level get increased. Let's say the water level is up to this position. Let's say that this is the increase in the water level due to the immersing of the cube. So let's denote it by h dash. This is the increase in the water level due to the immersing of the cube in the rectangular tank. Now what we see here, this portion is created due to the immersing of this cube. So we can say that the volume of this cube volume of the cube is equals to the volume of this portion of a cuboid, because this portion is created due to the volume of this cube. So the volume of the cube should be equals to the volume of this portion. So this portion is nothing but a cuboid having length 15, breadth that is same as 12, and height is h dash, that is increase in the level. So now we put the values. The volume of cube, that is a cube, that is 9 cube, should be equals to 15 into 12 into h dash. So h dash is equals to 9 cube divided by 15 into 12. So 9 cube is equals to 9 into 9 into 9, 15 into 12. Now we cancel with 3 5 times. Again we cancel with 3 4 times. So 9 into 9, that is 81 divided by 20, or you can say when 81 is divided by 20 we get 4.05 centimeters. So the increase in the water level in the rectangular tank is by 4.05 centimeters. Now we move to the next question.